2476 closest nodes queries in a boundary search tree. So for this problem, we are giving a boundary search tree, and we are giving the root node, and we are also giving a queries. So for each of the queries, so for example, I don't want to explain it, but everything I think it should be easy to understand. Let me just use the example to explain it. So for the first example, the first query is 2. So this means we're gonna find the maximum value that is less than and equal to 2. So it's gonna be a 2. And for this query 2, we're gonna find the minimum value that is more than and equal to 2. So it's gonna be a 2. And similarly for the query 5, so it's gonna be 4, and more than 5, it's gonna be 6. And similarly for this query 16, we're gonna find the maximum value that is less than and equal to 16. So it's going to be 15. And we're going to find the minimum value that is more than or equal to 16, but there's no such value, so we're going to give a -1. And similarly, for the values less than or equal to 2, if we cannot find it, we're going to give a -1, but currently we can't find it. So this is the idea of how to understand the problem. So if we understand the problem, the next step is that we are giving this kind of a boundary search tree. So if we are giving the boundary search tree, definitely we can put it inside an array and sort it in increasing order. So that's going to be n log n time. But we don't need to do that. We can use in-order traversal of the boundary search tree, because according to the properties of the boundary search tree, if we use in-order traversals, we're going to always go to the left. We're going to always go to the left first. So this is going to be the left side, and then we're going to go to the root node, and then we're going to go to the right side. So after the in-order traversal, we're going to get an increasing array, and then we're going to use the queries and to check it inside the increasing array. And we should know that if we're going to use a boundary search, it's going to be easier for us to find the maximum value, which is less than or equal to our current query, and it's easy for us to check the minimum value that is more than or equal to the query. Let me just start the in-order traversal first, and then explain how can we use a boundary search to solve the problem. So I'm going to define a DFS function. Basically, this is in-order traversal. I didn't write it in order because that is more characters, because DFS is easy to write. Okay, I'm going to prepare a result. This is going to be an empty array. So I'm going to get the result array after call the DFS for this kind of in-order traversal. So I'm going to give a root node and an empty array. Now I want to check if there's a node inside, so I'm going to run the in-order traversal. So it's going to be the DFS node.left with the result, and the result is going to append a node.value, and then I'm going to the DFS node.right and with result. So this is going to be the in-order traversal. After that, I'm going to return the result array. Now let me print out the result. You're going to check what is inside for the result array. Because later on we're going to use a boundary search. Basically, we need to check our result array. I'm going to give an empty array at the moment. Let me just run it to check what is inside the result array. So for the first example, let's check that. So we just have a increasing array. So like 1, 2, 4, 6, 9, 13, 14, and 15. That is for the values of all the nodes. And then we're going to use this array to solve the problem. Now let me just remove the print and prepare a final answer. So for the result array, because I'm going to use a boundary search, so I'm going to do some pre-process. I'm going to do some pre-process for the result array, because this is going to be easier for me to solve the problem. So I'm going to prepare a padding of -1 plus the result and plus infinity. And because according to our problem, if we didn't find the value at the left side, we're going to give a -1. For the right side, if we didn't find, we're going to give a -1. But we want to keep the array in increasing order. So at the right side, at the left side, it is okay for us to give a -1, because all the values in the result should be the positive integers. As we can see, the queries I the noise value is always be positive integers from 1 to 10 to the power of 6, so this is okay for us to give a -1 at the left side. But for the right side, we cannot give a -1, we have to give a infinity. So in this way, it is in increasing order. This is easy for us to use the boundary search later on. Now, let's just use the boundary search. So for Q inside the queries, first of all, we're going to check the left side. So I'm going to find the index, and going to be from the left side, as we are going to find the maximum value, which is less than or equal to our current value. So this means we're going to use a bisect left, and we're going to have the result array, and we're going to have the query. So we're going to prepare the minimum value at the left side. So the minimum going to be the result I. So if the result I equal to the Q, if we can find it, otherwise it must be the value before it. So it's going to be the result I -1. Yeah. So this before it, this result I -1 can be a -1 if we didn't find it, or it can be a value which is smaller than our current value. So for example, this is a 2, and inside of the boundary search, we're going to find this 2. But if this is let me find another value, maybe. So this is 2, we find the 2. Maybe there's another value, maybe it is 1.5. So where we can find the value which is less than 1.5, definitely it is this 1. So that is why we're going to use the result I -1. But what if the value is, what about our Q is 0.5? Yeah, that is just an example. Normally it's going to be integers. This means we cannot find the value for our bisect left. We cannot find it, but we have a -1. So this means we're going to return a -1. Similarly, we're going to prepare the right side. So the J going to equal to the bisect right. So it's going to be the result and the Q. So the maximum going to be equal to result. It's going to be result I. If result I not equal to infinity, because at the right side the maximum value going to be infinity. Otherwise we're gonna return a -1. Let's just use this kind of idea. Let me just print out the result to explain what do I mean by the right side, by the bisect right. This is wrong. Yeah, because I didn't return the answer, but it is okay. Let me just explain it. Yeah, as we can see this array, we have the positive infinity at the right side. So while we are checking a query, which is a 16, what's going to happen? So if it is a 16, this I going to be, the position of this j going to be here, because this value going to be more than 15. Since it is equal to the infinity, so we're going to give a -1. Yeah. So for example, if we are going to find 15, so the j's place is going to be here. We're going to directly return the result I. It should be okay. Yeah. Otherwise, so we're gonna find this result I gonna be the positive infinity. So we're gonna return a -1. So this is why. Now let me just run it to check. It seems the answer is not okay. Did I put anything inside the answer? No, I need to put something inside the answer. So the answer gonna append the array. It's going to be the minimum value and the maximum value. Now let me just run it. Now as you can see, it works. And let me just print out and delete the print and check if everything is okay. As you can see, it works. Now let me submit it. Yeah, as you can see, it works and it's pretty fast, and the time complexity is n log n. So from here, I don't think it's too difficult to write. So because this is just in order traversal, you just get increasing array, and from here you should use some trick. Or if you don't want to use a -1 or the positive infinity, you can directly use the result. But definitely you need a lot of check in these areas. So in order to avoid such kind of check, there is still some checks. If we are using the boundary search, if we cannot find the value or we can find the value, definitely there will be a check. But I think that is okay. No matter which way you're gonna use, definitely we need to do some tricks to solve the boundary search problem. So I think that's all for it. Thank you for watching. See you next time.